So as I said, we got started on this about 3 years ago when we heard about the maker movement and became really enthralled with everything it could do, meeting you, meeting Travis. We came back with a renewed appreciation about what to do with our lives in this second chapter, I guess. And we spent a lot of time checking out the landscape, the political landscape, all the opportunities in Connecticut, and trying to learn all the people that we could talk to find out how to move forward with the makerspace. One of the things that we did was put together this presentation to try and explain to people, because when you go around to a lot of people and say, hey, would you like to join us in putting up a makerspace? They really think you have two heads. And so we put together a presentation to try and explain to people what a makerspace is and why it's important and how that ties together with everything everyone does. So with everything that the educators do, the librarians do, the manufacturers do, all critical pieces. You ready?
Well, no video.
There you go.
Wait, there we go.
Something special happening across America. You see it everywhere. Doing yourself hands-on across the country, makers, doers, and those with a can-do attitude. Got this.
Americans are, we are makers. With our strengths and our minds and spirit, we gather, we form, and we fashion. Makers and shapers and put-it-togetherers.
I'm a maker.
We are makers.
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 We can't wait to see what you'll make.
Now, the purpose of that video was to kind of give you an idea of mainstream advertisers, mainstream companies are starting to embrace making, and that's pretty important. There's a lot of money behind that. There is an economic side to the maker movement. Senator Mark Takano started the Maker Caucus at Capitol Hill. I'm going to play with the sound.
And so it's Congressman Mark Takano, and we were kind of surprised to understand that there was a Maker Caucus on Capitol Hill because we hadn't heard that much about it. But luckily, a couple years ago, we were invited to attend. And you can see that that's Mark Takano in the center. Dale Doherty is there on the left. Stephanie Santoso. And it was really illuminating at that time to understand what the Capitol Hill was trying to do to support all of us in these efforts, and that they were actually thinking of supporting us in these efforts.
These are just some various statistics, but you know, the numbers are billions and in some cases trillions when they talk about the Internet of Things. Cisco, in fact, estimates that the Internet of Things, which is physical devices connected to the Internet or networked in some way, so it's not just your computer and your network. Now we're affecting things in the real world, like telepresence or robots controlled at a distance or sensor networks, things like that. And Cisco estimates that's going to be worth 19 trillion in 2020. And makerspaces and hackerspaces are a phenomenal place. All you need is a good idea, something no one's quite thought of before. You come up with a prototype, maybe do a Kickstarter, and Kickstarter these days is considered proof of concept by venture capital. So if you do well on Kickstarter, you get a good shot from there. That was NASA. They were at the Maker Fair, and you know, they're definitely showing off their toys and all the stuff they have, but I also think they're sort of looking for talent, because makers are problem solvers. They're not afraid to dive in and fix something. Or, you know, the NASA engineers are famous for just, you know, you got this intractable problem. How do we solve it? And they'd usually come up with some oddball idea way off the beaten path, but it worked. You know, put man on the moon. Grommet is a place that, supports makers. You can list, whatever it is that you make for sale, and it's the story that sells the items. If you're going to be buying stuff for the holidays, for Christmas, and you want something handmade, something made in the U.S., something with a story to it, you can go to Hartford Denim, for sure, and you can also go to Grommet, where there is, a wide variety of handmade items with a story to it. And I kind of like the bicycle wheel, because you're like, so what? It's a bunch of lights on a wheel, but in reality it is one light bar. And as the bicycle wheel rotates due to persistence of vision and computer control, you get these amazing patterns, and you can switch them. There's many different patterns. It's like $70. And they actually have one that does full motion video. Imagine that, riding around at night in the city with video and maybe a soundtrack, It's pretty cool. So the maker movement's driving engineering into the mainstream. Makers around the world are inspiring each other to create or make smart gadget, robotic gizmos, autonomous drones, wearable devices. You don't have to be a multi-million-dollar company anymore, to get involved in this stuff, especially with the power of Arduino. So makers work in home garages and collaborative workspaces with their peer, and many times they openly share their inventions, which is, great, inspires others. So this type of grassroots viral innovation is disrupting the status quo. Is this the beginning of the next industrial revolution? I think that's pretty clear myself. Oops. This is actually a key slide. You want to take this one?
This basically addresses how we're disrupting the old paradigm of education and employment. In our old life, the one that many of us went to, we basically started out getting our education. Most of us went to a 4-year school for a degree. At that point, our parents prayed and hoped that a business would hire us. Once we got a job, the company we worked for either told us to create a certain invention, or they created a certain invention that we had to market, and then the marketing departments basically foisted urgency on the consumer, and we learned that we really needed to have this product. In the new paradigm, basically, a lot of the consumers are makers themselves. They're educated, they know there's a product that they want. If they can't find it, they create it themselves. At that point, they start their business, they have their invention, and then they get just enough education to forward their business and their product. The world is sort of turned around upside down.
Now this is something I call the new tech economy, and I think it kind of shows you where the power of the maker revolution comes from. I think it all starts with maker ideas. When I say maker, you start to hang around with people that do making, and there's sort of a certain mindset. They typically do coding, sometimes they do CNC machining, just certain things that makers tend to do. And they think outside the box. So it all starts with an idea. Inventions, both hardware and software, Internet of Things, tech of all kinds, derivative and collaborative works, and traditional skills too. But anyways, so it starts with an idea. And then you add some resources to the mix. Maker spaces, large and small, fab labs, hacker spaces, innovation centers, co-working spaces, accelerators, mentoring. So now you've got some tools to actually make something. And maker activities. Again, if you go to a maker space, you're going to get exposed to CNC machining, laser cutting, electronics, robotics, wood and plastic fab, welding. You may not learn all of these, but you'll probably learn some of them. Maker marketing and sales. It's unbelievable. I mean, I used to have a product that I wanted to market years back, and that was before, the internet was really like a big thing. It was hard. Now, Grommet, Etsy, Amazon Marketplace, eBay stores. There's all these different ways to market. Maker education, and getting back to, you hang around the maker space, you tend to learn certain things. Programming code, Arduino, Raspberry Pi, electronics and robotics, CAD/CAM. CAD/CAM, for those of you who don't know, CAD is computer-aided design, where you make a computer model of a part, and then the CAM part is how you tell the machine to actually make that part. Creative software, maker classes, maker branding, again, social media, Facebook, Twitter, Reddit, so on. Maker collaboration, makers work together, web groups and forums, hobbyist groups, local user groups, artisans associations, professional associations. And then the new part, the funding. There's new legislation, that's not new anymore, but it basically opened the door to soliciting investment. And that was illegal before. And now there are maker funding sources like Kickstarter, GoFundMe, Indiegogo, Fundable, Fund Anything, and many, many more. So now you're adding the funding component. So when you add all that together, how can you not have innovation? I think it all sort of feeds into itself. And the result, the creation of small businesses, which provide most new jobs in this country. You provide people new job skills, you increase their marketability, you find a better fit for more people. You know, let's say you go into a makerspace and you really like the laser cutter and you're really artistic with it and you start selling things. Well, you may not start a big company, but maybe you find a job that you like, you know, and your life really is perfect because you're doing what you like and you're making a living at it, and that's good. So a better fit for more people, increase high-tech and advanced manufacturing in Connecticut will encourage younger people to get into these more high-tech pursuits, and a significant decrease in the skills gap. The next slide is just a little bit about the stakeholders. I think the large maker spaces and what we're trying to do is form a liaison with the government, and that's kind of why we're in the middle. You know, to advise them on policy, to explain to them what making is, why it's important. You know, if they want to encourage making, we can help them understand how to do that. And then there's a number of other, you know, types of entities that should be involved. Business, nonprofits, museums, libraries, small maker spaces, labor unions, schools, consumers, makers. You know, they all have a vested interest. This is actually a bridge. This isn't a rendering, but they actually are planning to build this. I think it's in Amsterdam, and it just prints the bridge as it goes. You know, it prints it and moves across, and you can't build something like that any other way. It's extremely lightweight, extremely strong, and additive manufacturing is the only realistic way to do something like that. This is a short video. Let's see if we can get it to play here.
I'm David Bartosik, and I'm an engineer here at GE's Additive Development Center. And what we've built is a miniature turbine engine. This is built using an additive process called DMLM. One of the big advantages of this process is you can redesign your parts with new geometries and new alloys that typically aren't available because you're building your parts layer by layer. From there, we continued the design for the rest of the engine and then printed these parts in EOS M270 machines. We're using high-strength, high-temperature alloys that typically aren't available for the RC industry. There's some post-processing that has to occur, some machining and polishing of different parts. And we assembled our engine, rigged up some data acquisition systems, mostly for exhaust gas temperature and engine speed.
Normally about now you'd have a really nice paperweight.
And then we tested this engine in a test cell at GE Aviation in Evendale.
So that motor hit something like 30,000 RPMs. That's on par with a commercial jet engine. In fact, there are parts in service now that were 3D printed in aircraft engines. So it's pretty amazing technology. It's here, it's now. This talks about some of the educational benefits of making, you know, learning by doing, iterating on ideas, and collaborating with peers. This is a, you know, take on the old quote, if you teach a kid to fish, you know, maker skills last a lifetime. The skills you learn may get you a better job. They may look better on your resume. They're likely to be important. Chief Technology Officer of the U.S. government, or the White House, that's Megan Smith. She is the former VP of Innovation at Google, and she left Google to take the post at the White House. And she says, we have wonderful, wonderful teachers who can't disrupt their industry because it's so constrained and bureaucratic. We need to make school way less boring. Instead, a great way to learn is project-based learning. one of the most important things we need to do in the U.S. is to empower kids to be makers rather than consumers. Project-based learning is more effective and less expensive, maybe. All the kids need to be able to do that. The world becomes a classroom, instruction comes from the topic because you need it, people collaborate on real stuff. Now that's probably difficult to implement for a lot of reasons, but it's certainly something to inspire to. Whole world runs on code, and this is a play on the matrix. The thing is, anything electronic these days probably has a microprocessor in it. And the microprocessor in the Arduino boards is actually a commercial unit that's used in microwaves and remote controls, phones, all kinds of stuff. So learning how to code is actually very powerful, and it's a vital skill. We should be teaching it to our younger students. I think England teaches their students in the 2nd grade. Vietnam is teaching all their students. They get it. They're doing it. The White House promotes making because they feel it's a way to spur the economy. It's a way to help close up the skills gap and make us more competitive. We need to get more students into the, STEM fields, science, technology, engineering, and math. And my thought is, hey kid, you want to learn some STEM? Huh? No? All right, well, you want to 3D print, or do you want to make a robot, or do you want to hack your phone? Sounds a lot more engaging to me, and that's the beauty of making. So the White House actually put out a couple challenges. One was called the Mayor Maker Challenge, where they encouraged mayors of different cities to do one of many different maker activities, like holding a conference or opening a maker space or a round table. And they sent out a similar one to universities and colleges, also, encouraging them to make. This is an overview of the Colt building. We will actually be in the bottom floor of that number 3 building. And that is the actual building where they made all the guns and stuff that helped make America, or not America, but Hartford, a real industrial powerhouse. They perfected the use of interchangeable parts at Colt, and that went on to help spur the Industrial Revolution. Connecticut, New England, we have a lot of industry clusters in advanced manufacturing, aerospace, defense, precision machining, medical devices, biotechnology, optics, semiconductors and complex electronics, signal processing, navigation technology, measurement tech. For a small state, we sure have a lot of expertise. Connecticut does something like, I think, $19.4 billion in advanced manufacturing every year. And the skills gap. Employers need employees that are critical thinkers, problem solvers, good communicators, team players. And we feel that making is a way to spur some of these STEM initiatives in a way that really appeals to the younger kids. So that's the end of this presentation. Deb, did you want to?
And thank you for bearing with us for this time. We'd like to invite our exhibitors and makers and our team, our planning team, all up to the stage for a moment, please. And I'd like to invite Mark Mathias from Westport Maker Fair, who was kind enough to create a few wonderful gifts for everyone. So, Mark has a wonderful initiative going regarding the Connecticut State of Innovation license plates, and was kind enough to make some license plates for all of our exhibitors and sponsors, and sponsors, if there are any of them left here, please. I see perhaps one. So, the Connecticut Educational Network. Do we have someone here from the CEN? Okay, we'll skip that. Mastercam, I think they went home already. UHeart EC.
Shell.
Beautiful.
Thank you. Awesome. Thank you.
Tom Rutledge. Thank you. CCAT. Mr. Paul, thank you very much for participating. JCJ went home already. Melissa Toms, our librarian. Oh, there we go.
Oh my God! I have my own.
Maker rock star.
Dale Doherty? Where is Dale? Dale, I know is still here.
Dale.
Thank you. Very nice. I appreciate
In a sec.
Did you mention the innovation state, special license plates and all that?
I'll
Yeah,
bring that in a
yeah,
second.
we'll do that in a
So
second.
these are the-
So we've got our speakers, Tia Capps.
Is Tia here?
Is Tia, I know she's still here. We got one for you, Tia, that you can bring back to Chattanooga.
Tia's at our mercy right now.
Oh, she's in high heels.
There you go.
Everybody stay up here. We'll do a shot with everyone else.
And is Bonnie Koba still here? Okay. Bryan Patton? Yeah, you.
Thank you.
Balam Soto.
There you go.
Thank you.
Ken Butler left. He's the musician. Oh, this is the longest name in the group. Devra Sisitsky. And the musician and Mark Hatch. And as our last moment, what I'd like to do is thank everyone on our team. I'd like to give them a certificate of recognition for all the work that they've done over this past year, I would say. It's been wonderful. Melissa, got one more for you. I will. And so this is a certificate of recognition proudly presented to Melissa Tom, our librarian, for recognition of service above self for your efforts above and beyond to establish the first annual New England Maker Summit and promoting maker activities.
Thank you.
Shelley McMillan. Thank you very much, Shelley. We wouldn't be here without you. Balam Soto, thank you for the planning. Paul Sturvell, thank you very much. And we have one for Scott Phillips. And we'd like to thank, and we'd like to have Mark say a word.
These license plates that you've seen, just to let you know, these are actual real license plates that have been, the design has been approved by the Connecticut Department of Motor Vehicles. You can actually sign up, you can transfer your existing license plate or get what's called a vanity plate. I have some forms over here, or you can go to stateofinnovation.org to download this stuff. So please spread the word. We need to get 400 orders and the DMB will press these for us. So please go ahead and stateofinnovation.org, get the forms for me.
Thank you, Mark, appreciate it. Thank you, everyone, for bearing with us. It was a long day, and we'd love for all of you to stay in touch as we move forward, trying to get some more awareness and activity and support around the world of making. Thank you.